Right, ladies and gentlemen, we meet again by the grace of God. Vandaag, I want us to look at this previous question paper that was written 2016 March on the 23rd, 23 March 2016. So question 1, I want us to look at question 1. As you can see, they are saying it's compulsory. You understand? So you must read the instruction. So the instructions are very much important. You see, they are saying answer question 1 and any 3 amongst the 4 remaining. You'll be given question 1 up to 5, question 1 up to 5. Question 1 is compulsory, and amongst the 4 you select 3. You understand? So in most of the time it's always question 1 compulsory. Understand? So it reads as follows. Figure 1, diagram sheet 2.1 attached show 2 views of a square to round transmission piece. This is a square to round transmission piece. So it's usually be an advantage to an entry a learner who has passed his or her N2. You understand? Because we did this transmission of square to round graphically. So the only difference here in N3 is that you'll be now doing it mathematically. You understand? So note, no marks will be awarded for a length taken from the drawing to a scale, which means we do not have to use a graphical method, but you have to use the mathematical one. So number 1, draw the given views will be given 2 marks, regardless of you draw them according to a scale. You understand? 1 mark for the front view, 1 mark for the top view. So calculate the true length, show all the calculations, 10 marks. Use the information from question 1.2 above and develop the half development of the transmission piece. So I would like to underline the word half pattern or half development. So we are not being asked to draw the full development in this case. We have to draw what? A half development. So using a scale of what? Of 1:1, which is figure what? Figure 1, diagram sheet 1. So let's go. So which is the figure 1, which is this one. So the very first thing that we have to do here, we have to draw this figure 1 the way as it is, using a scale of 1:1. So let's start. So let's draw together. I draw a line, you also draw a line. I draw a line, you also draw a line there. So I'll start with the what? With the line horizontally. My drawing table seems to be a bit small. So I'll start just a little bit up on my left hand side from the drawing sheet. So these lines are perpendicular to each other and I've drawn them faint. You understand? So from here going up, I'm going to record what the dimension, 50, which is the height, 50 millimeter. Centimeter, what is going on? So forget about this one for now, even though it's the same, but let's use the proper gadgets. So the set is 50, so there is my 50. So where my 50 is, I can draw a faint horizontally, then I record 20 millimeter. You understand? And I draw a horizontal faint line. So orthographic projection says separate your views with 20 millimeter, isn't it? Always separate your views with 20 millimeter. So from here going down, I can record the 90, because the set from here till there is 90 millimeter and it's a square. We know the properties of the square, so all the sides they must be equal 90. Right. So from where my 20 ends, I record a dimension of 90. Do you see where is my 90 ending? It's 80, 90, and I can draw a dark line now. And what is the half of 90 is 45. I mark at 45. You understand? So then where my 90 ends, I draw a faint line and I draw a center horizontally line. Then I can come whether on this one or the center or this one, it will be still one and the same thing. So the half of 90, so that I get the vertical center, isn't it? There is 45, so the 90 is right there. So my center must exceed my drawing. So this is the vertical center line. It's going to start up from my front view. So have it faint, but from here till there, solid. Don't understand. So I can have this one solid again. Solid again. Solid again. So this is the bottom part line of my front view. So we are told that remember they said it's a square around the round part, upper part of it, they said is diameter 72. So you can take your drawing compass, yeah. Then now I'm going to say 72 divide by 72 divide by 2 is 36, right? So I'm going to open my drawing compass to 36. 36. There's my 35. 36 is this one. So now I can place it where the two centers are perpendicular to each other, there by my top view, and have this one. So that's diameter 72. So then I can project these circumferences and this one up there. So now the upper part of my front view is going to be now dark from here till there. You understand? So now I can join this one. Before you think that is at a certain angle, it's not up at an angle, right? So remember the question said a half what? Half development. Half development. So it's going to be up to you, since we are not given the cutting thing, whether it's cutting like this or it's cutting like this. You understand? We are not given. So whatever number or your starting point is, it's going to be acceptable as long as at the end of the day you cut it half, whether horizontally or vertically. It will be one and the same thing. Yeah, you understand? So from there I am going to let me firstly divide my circle into 12 equal parts. Divide my circle into 12 equal parts. There you go. Strike an arc there. Remember, I've got two methods of dividing the circle into 12 equal parts. So vandaag, I just decided to use this one. There you go. Understand? So I'm going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. You understand? So now There we go. There we go. Like this we go. Like that to go. So let me do it all. There we go. There we go. There we go. There we go. This one. See. Yes, right. So now I'll decide to say I have what, a here and a B here and a C and a D. So in this case I decide to take this bottom part. When I can decide to take the upper part, you can still have a B, C, D. You understand? You can still say A, B, C, as long as you are going to develop the half development, my brother. So now let me complete my front view by saying point 1 and 11, they are going to be in the same point. Point 10 and 2, point 3 and 9, they're already there. 4 and 8, and the 5 and the 7. You understand? Because I'm trying to accommodate the front view complete. You understand? Because I don't want to lose that single mark. So let me complete it like this, like that. Here we go. Here we can go. It will go like this and like that. So I believe in the final examination, if they can say time up, about 2 out of 25% is already in my pocket. You understand? So in this case, it is very much important to dimension your work. To dimension your work. So we knew from here till the A to B is 90 millimeters. You understand? So I can simply say A to B is what? Is 45 millimeters. 45 millimeters. You understand? Excuse me. And the height, what is the height? The height, it will be always dimensioned there by your front view. So the height is 50 millimeters. You understand? It's 50 millimeters. So now the diameter, the set is how much? The set is diameter 72. So if it's diameter 72, so if we divide 72 into 2, we get 36. So which means I can say 36 this side and 36 this side. So it is very much important to scatter or to divide your points like this. I forgot this one. Take it. A to 9 supposed to be there. So it is very much important because we are going to use the mathematical method here. You understand? So now we know the distance of R. Let me decide to name this one R. Stands for the reference. R. A derivative of R, because we are going to have another small letter R. This one is capital letter R. Okay, so from R to 0 we know the distance of from R to 0. We know, we are told, we are given. We do not even have to calculate for it. We are given that one, which they said is how much? You say 36. Then the distance from R to A, we know again is 45. So the distance that we don't know is which one? Is from D to 0. From D to 0. And let me put the cutting plane. So my cutting plane, I will say they've cutted it. Oh, they've cutted it right here. They've cutted it like this. You understand? So point D and X, they are actually in the same, and C and X, they're actually in the same point according to your top view. Okay, I'm trying to be very slow so that I don't repeat this lesson. Okay, so now I'm going to say my first step. Let me say step 1. Step 1. Let's calculate, let's get the distance of D0 in the bottom part before we consider the height. So we are going to say 45 minus 36. How much are you getting? 45 minus 36. So this 45 is this is the half of what? Of 90, isn't it? So 45 minus 36 is 9 millimeter. So we are getting 9 millimeter, isn't it? So this 9 millimeter is which one? It's going to be that one from here till there is 9 millimeter. So the 9 millimeter, it should be right. It should be right there. 9 millimeter. Okay. So now, since we do not have the true length diagram, I can erase this one. So I'm going to say now step 2. Let's calculate the distance of D0, including the height now. We said the distance of D0 excluding the height is 9 millimeter. We have to include the height now, which is what? Which is 50. So if I can dimension that one in there by my front view, we are saying this D is here and A, isn't it? So from here till there is how much? It's 9 millimeter. You understand? It's 9 millimeter from here till there. So but then let's conclude, because this D actually is actually up, I mean 0, because this is D, this is 0. It's actually up there. You understand? So let's consider the height. So if we consider the height, I can now say there by my step 2, I will say the distance of D0 is equals to square root of x squared plus y squared plus the height. Understand? So my x is going to be what? My x is going to be 9 millimeter. My x is going to be 9. I hope it's still clear. So I'll substitute my x squared with what? With 9 millimeter, which is that one. So my y is going to be 0 squared, and the height is how much? Is 50, isn't it? It's going to be 50 millimeter. Why my y is 0? Because we didn't move any inch along the y-axis. You understand? So if you have this type of a calculator, you can simply punch it the way as you can see it. So open bracket 9 squared plus 0 squared plus my height. Don't forget the height. So I am getting 50.804, isn't it? But then please use round it off, because we are going to take this dimension to our diagrams, isn't it? So we need exact. So please use 51 millimeter. That's your proper answer. So the distance of D0 is what? Is 51 millimeter. So, and remember that this is a square, so from D to 0 is 51, from C to 6 is still the same as what? C, which means in other ways we've already gotten the distance of what? Of C6. Remember, this is A, B, C, D. You understand? So we've already gotten the distance of C6, which means I can say, therefore the distance of D0 is the same as distance of what? Of C6, which is what? Which is 51 millimeter. You can quote it like this. Hey, one. Alright, so now let me erase here. So they need this mathematics a solution. Remember, the set is how much? Is 10 marks. You can bear to lose 10 marks. And even if you know how is the development is going to look like, without these mathematics steps, they are not even going to consider your solution. They'll only consider the given view only. You understand? So they will be like, how did you develop without your calculation? You understand? So my step 3, in step 3, so now I've gotten what? The distance of D0, including the height, isn't it? D0, including the height. So now let me get the what now? The distance of DA. The distance of DA, do we have to calculate it? No, we do not have to calculate it. It was given, which is how much? Is 45 millimeter. 45 millimeter it was. So the distance of DA, we do not have to calculate it. We'll just take it the way as we can say it. So the distance of D0 we've already gotten. It is 9 millimeter, excluding the height. Including the height is 51. So now the distance that we have to calculate is A0. A0. Remember, you said you said 0, 1, 2, 3. You understand? So let's calculate the distance of A0. And we know what the distance of A0 is supposed to be the same as B6. Are we together? So now if we calculate the distance of A0, I'm going to say A0 is equals to square root x squared plus y squared. Do not forget your height, perpendicular height squared, perpendicular height. So why are they saying perpendicular height? Which means you have to consider this one. Once it's now at this point, you go up. You can see that it's perpendicular. It's not at a certain angle. So now how am I going to substitute x? So x is going to be your 9 millimeter squared plus, and then your y. Remember, we are at A0. So from here till here, my y is going to be what? 45. The one that is given. So plus your perpendicular height, which is standard one, doesn't change. So this is going to be the distance of what? Of A0. So you can simply punch it the way as you can see it. So open bracket 9 squared plus open bracket 45 close squared plus your height 50, isn't it? Yes. So simplify it. So the distance of A0 is going to be 67.8 and 8. So but you must say, therefore please use this is your answer, but please use 68 millimeter in your development. All together. Right, so we've calculated the distance. Let's go back to our top view. We calculated the distance of A0, but now do not forget the distance of 0, 1. And we said we are dividing the circle into 12 equal parts, isn't it? So 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, up until back to what? To 12. These are equally spaced. We said we are dividing this circle into 12 equal parts, but we have to get that value of it. You understand? So the value of it, the value of that arc is how long is that arc of it, of diameter 72. How long is the arc of diameter 72? So to get that one, we are going to say L is equal, so this L I would be like is stand for the length of our development, and this is step 4, isn't it? L is equals to pi diameter over 12. You understand? So whereby L represent the length of our development, isn't it? So the value of pi, you know it. If you don't know it, you just substitute pi the way as you can see it right from your scientific calculator. So how are you going to substitute D? So D is the diameter, isn't it? Diameter, so we're going to say diameter 72, yeah, all over 12. So L is equals to, so we're going to say, so let me do it like this. So second function, so you can press second function, and then you go to the symbol of pi, then the surface diameter is 72, isn't it? So go to your denominator is 12, so they are saying is 19.1111. so you are going to use 19 millimeter the way as you can see it. So the no, is it? It's 72, not 73. 72. Please correct me that one. So simplify it. So it's 18. Yes, you can erase that. So it's the diameter. It was 72, not 73. So excuse me on that one. So it's 18.8495. So you must say, therefore please use 19 millimeter. That's the length of the arc. Right. So after we've gotten our step 4, so what is going to happen now? So now we are going to calculate the distance of what? Of A11. To you, it can be like it's A1, you understand? And the distance of A11 is supposed to be the same as A10. The distance of A0 is supposed to be the same as A9. The distance of A11, A10 must be the same as B7, B8. Are we together? So which means now I can have what we call an imaginary right triangle that it can be like this, you understand, and direct it to what? To a reference point. To your reference point. Right. So if we are going to have that a right triangle, so if I can take it out for you, zoom it out right from the top view, you understand, from the top view, and take it out